All right, Math 2, Unit 7, Special Right Triangles. This entire unit is about right triangles. We have two that we call special because they have special ratios. The first one we're going to talk about is a 45, 45, 90 right triangle. You should realize that since the base angles are congruent, that this is an isosceles triangle, meaning these two side lengths are congruent. So in a 45, 45, 90 right triangle, first thing you want to know is that the two legs, okay, we call the sides that create the right angle the legs. The two legs will be congruent, and the side opposite the right angle is always called the hypotenuse. Okay, that should be review. So in a 45, 45, 90 right triangle, the ratio is the side lengths equal 1, then the hypotenuse would equal square root 2. So the ratio is 1 to square root 2. All right? Another way we can think of this, what I mentioned yesterday, is if the side length equals A, then the hypotenuse will equal A times the square root of 2. So whatever the side length is, the hypotenuse will simply be the side length times square root 2. Does that make sense? All right, so in this case, the hypotenuse equals the square root of 2 when the unit ratio or the unit side is 1. We call that the unit ratio. When the leg is 1, the hypotenuse is square root 2. Questions on 45, 45, 90 special right triangles? Okay? The second one we have is the 30, 60, 90 right triangle. And obviously, the 30-degree angle will always be across from what we call the short leg. The 60-degree angle will always be across from what we call the longer leg. And, of course, the hypotenuse is always across from the right angle. Okay? Now, the ratio we talk about here is if the short leg is 1, the longer leg will be the square root of 3, and the hypotenuse will be 2. Okay? So in a 30, 60, 90 right triangle, the ratio of the short leg to the long leg to the hypotenuse is 1, square root 3, 2. So in this case, the longer leg is equal to the square root of 3, and the hypotenuse would equal 2. All right? And another way we talked about that is yesterday. It's still up on the board over there. If the short leg was A, the hypotenuse is going to be 2A, and the longer leg is simply going to be A times the square root of 3. All right, so let's jump right in. Let's do some questions here. So on these things, the first thing you'd like to do is you want to identify special right triangles. All right, in this unit, there are basically going to be 3 ways you solve questions. One is using the Pythagorean theorem. If you are given all 3 side lengths of an equation, or if you're given 2 and asked to find the third, you can use Pythagorean theorem. Okay? If you're only given 1 side length, but you're given an interior angle, and one of those interior angles is either 30, 60, or 45, you know you're going to use the special right triangle rules. And then probably Monday we will get into trigonometry. So when I look at this question, I go, okay, I'm only given 1 side length, but I do know that this is a 45, 45, 90 right triangle. So I know I'm going to use special right triangle rules here. Does that make sense? So that's how I evaluate how to solve a problem. So if this side length is 8, what does x equal? 8, because we know a 45, 45, 90 right triangle is isosceles, so these two legs have to be the same. Now, if this is a 45, 45, 90, what do we know the hypotenuse has to equal? 8 square root 2. It's that simple. We simply take the leg length and multiply it times square root 2. That's all we're doing. All right, let's go on over to number 2 here. So again, we only have 1 side length, We're looking for the other two, but we do know that this is a 45, 45, 90 right triangle. So if one leg is equal to 25, what does the other leg equal? 25. And what does the hypotenuse equal? 25 times the square root of 2. Pretty simple so far? Okay. Well, here's where it gets a little bit trickier. Again, I'm only given one side length, and I know it's a 45, 45, 90 right triangle. So I know x and y are going to be the same. But this is the tricky one. When we have gone from the leg length to the hypotenuse, we've multiplied the leg length by square root 2 to find the hypotenuse, correct? So to go from the hypotenuse to the leg length, we have to do the opposite, or divide by the square root of 2. So if the hypotenuse of a 45, 45, 90 right triangle is 19, then the leg length is going to be 19 divided by the square root of 2. But remember, the only part here, we can't leave that in the denominator, so we have to rationalize it, which means multiply top and bottom by the square root of 2, which means we at the top we get 19 times the square root of 2. We can't simplify that. But on the bottom, anytime you multiply two identical radicals together, you get what's inside. Okay, so y equals 19 root 2 over 2. I know it's not very pretty, but it's pretty simple. And that's it. Okay, so it's really simple. In a 45, 45, 90, if you know the leg length, you know both leg lengths. If you know a leg length, you simply take that leg length and multiply it by the square root of 2 to get your hypotenuse. Good enough? If you have the hypotenuse in a 45, 45, 90 right triangle, to find the leg length, you simply divide the hypotenuse by square root 2. Simple enough, right? All right, let's go on to 30, 60, 90s. All right, in the 30, 60, 90, again, you'll notice we are given one side length and we're given an angle. And now we can identify this as a 30, 60, 90 right triangle. Okay, so I like to think about everything based off the short leg in a 30, 60, 90. But a lot of times you're not given the short leg. So it's a roundabout way. If you're given the hypotenuse, we're going to have to go around the horn this way. To get from the hypotenuse to the short leg, we have to divide by 2, which would mean 46 divided by 2, y equals 23. Does that make sense? Okay, and then to get from the short leg to the long leg, you have to multiply by the square root of 3. So if the short leg is 23, the long leg is going to be 23 times the square root of 3. Simple enough? Okay, now this is the harder one, when you have to go from the long leg to the short leg to the hypotenuse. So when we're going around the horn this way, from the long leg to the short leg, the first thing you have to do is actually divide by the square root of 3. That's the tricky part. Okay? So in this case, to find y, we have to take 20 and divide it by the square root of 3. And we would be done. It'd be that simple, but we can't leave that square root in the denominator, can we? So we're going to go ahead and multiply top and bottom by the square root of 3. And we end up with 20 root 3 over 3. Easy enough? Okay? So that's what y equals. Now, to go from the short leg to the hypotenuse, we simply multiply by 2, don't we? So it's pretty easy. If we know that y is 20 root 3 over 3, to get the hypotenuse, or x, we simply multiply it by 2. 20 times 2 is 40, and it's 40 root 3 over 3.
So you wouldn't multiply what's inside the square
It's all one thing, so you just multiply it once. Make sense? Here, no? Okay. This is the tricky one. So look at x, let me do it a little bit. X equals 2 times 20 root 3 over 3. Well, what would we do? We could multiply it times here. And if we could divide, but you can't. 20 times 2 is 40, and that's it. We don't distribute it or anything because it's 20 root 3 over 3 is just one thing. If there was a plus or a minus sign in there, then yeah, we would distribute. 20 times 2 is 40 root 3 over 3. Okay? All right, let's do some more. Okay, I'm really trying to emphasize when you use special right triangles. When you know one side length and you're given an angle measure that is either 45, 30, or 60. All of these are special right triangles, but in the future they'll be mixed up, won't they? So identify how many sides do I know? Only one. Do I have an angle measure? Yes, I do. This is a 45, 45, 90. So if one leg length is 4, I know the other is 4. And y is simply 4 times the square root of 2. Because that's just the ratio. Okay, I can show you, I could prove it using Pythagorean theorem. Okay, real quickly, Pythagorean theorem, a squared plus b squared equals c squared, correct? Well, if this is a isosceles triangle, if this side is 4, we know that side's 4. That's pretty clear, right? Well, that would be 4 squared plus 4 squared equals c squared, which means 16 plus 16, or 32, equals c squared, right? Take the square root of both sides, and we get the square root of 16 times 2 equals the square root of c squared is c, correct? What's the square root of 16? 4. So that means 4 root 2.
Where'd you get the times 2 from?
Because 32 is 2 times 16. And the square root of 16 is 4. So this is why special right triangle 45, 45, 90 works. Okay? All right. So here's the tricky one. You know one side length. You know it's a 45, 45, 90. So to go from hypotenuse to leg length in a 45, 45, 90, we take the hypotenuse and we divide it by the square root of 2. Okay? We rationalize the denominator. We get 28 root 2 over 2, which can be simplified, can it? Y equals 14 root 2, because divide both sides, top and bottom, by 2. Okay? So if y is 14 root 2, what does x equal? 14 root 2. Very good. All right, let's move on. Again, we know one side length. We know this is a 30, 60, 90 right triangle, though. So if you remember, when you go from the long leg to the short leg, you divide by square root 3, correct? So this one's pretty easy. If the long leg is 15 root 3, what's x equal? 15, because we just dropped that square root 3. Or you could really, what you're doing is 15 root 3 divided by root 3 is just 15. And now that we know x is 15, what's y? 30. You just multiply it by 2. Okay? Let's go on. Again, we know one side length, but we do know it's a 30, 60, 90 right triangle. This is the tricky one, to be honest with you. If the long leg is 6, then the short leg is going to be 6 divided by the square root of 3. We have to rationalize. We multiply top and bottom by the square root of 3. We end up with 6 root 3 over 3. which reduces to 2 root 3. So y is 2 root 3, which means x, your hypotenuse, is, double it, 2 times 2 root 3 is 4 root 3. Easy peasy? No.
When you did the y part and then like distributed or whatever, you got 6 root 3. Why did you change it to 2 root 3?
Because 6 times root 3 is 6 root 3, right?
Yeah.
Square root 3 times square root 3 is 3, and then we reduced. 3 goes into 3 once, 3 goes into 6 twice.
Okay.
Sorry that I left that out. All right, and look at that. Here we are getting trickier already. We are just never satisfied. Okay, solve for the variable. All right, so let's see what we got here. Well, we know this is a 30, 60, 90 right triangle, and we should know that this is a 45, 45, 90, right?
Yeah.
Okay, then we have to decide what side length do we know? Okay, we know the short leg of a 30, 60, 90, correct? So if this short leg is 9, what is the hypotenuse, or z? 18. 9 times 2, right? To go from the short leg to the hypotenuse of a 30, 60, 90, you double it. Multiply by 2. Okay, now we need to find x and y, but we can't find x and y until we know the hypotenuse, right? Well, the hypotenuse of the 45, 90 is actually the long leg of the 30, 60, 90, isn't it? And if the short leg is 9, the long leg is 9 root 3. Okay, this one's going to be a tricky one, right? Does everybody understand how I got 9 root 3 for the hypotenuse? Well, the short leg of a 30, 60, 90, let me just redraw that 30, 60, 90 right here. You guys see that okay? We were given 9, and we said the hypotenuse was 18. But remember, when you go from the short leg of a 30, 60, 90 to the long leg, you multiply by square root 3. So that's how I know this side, this length is 9 root 3. But now it's the hypotenuse of a 45, 45, 90, isn't it?
Yeah.
Here's where it's going to get tricky, guys. It's not really any harder. It's just to find x, we know that we take the hypotenuse, 9 root 3, and divide it by the square root of 2. Yeah? Now we have to rationalize. I know this is fun. You guys are loving this. So what is 9 root 3 times the square root of 2? Put them under the same roof. 3 times 2 is 6. So it's 9 root 6. Does everybody understand how I got 9 root 3 times root 2 and got 9 root 6?
Yeah.
And square root 2 times square root 2 is just 2. Now, if we could simplify this, we would, but we can't. You can only reduce with what's outside. So if x is 9 root 6 over 2, then y is 9 root 6 over 2. Fun, huh? You guys enjoying this? It's good stuff. Okay. Let's go over and do this one. All right. So you'll notice in this whole figure, we only know one side length. So I'm thinking this is special right triangle. Yep, this is a 45, 45, 90. This is a 30, 60, 90. So if this is 32, what's x?
32.
Good job. 32 square root 2. But we need this side, but we already know it. It's 32. So let's just separate out this 30, 60, 90 right triangle. Maybe it'll make it a little easier for us. Okay, so we know that this is 32, which means the hypotenuse is 32. Okay. So if the hypotenuse is 32, we know the short leg z in this case is 16. 32 divided by 2. And if the short leg is 16, the long leg y is 16 root 3. Good job. So really the only time it's difficult is when you go from the hypotenuse of a 45, 45, 90 to the leg length, or when you go from the long leg of a 30, 60, 90 to the short leg, right? That's the only time it's tricky. What do you guys think? Can we do them? All right, let's get started on, well, what we're going to do today, we're going to do the odds of worksheet 2. We're going to do the odds, but I think what we'll do is we'll get started. We'll go over our Unit 6 tests, and then we'll get started on it, okay?
Yeah,